we have covered adding on paper, subtracting on paper, and multiplying on paper. It is now time to talk about dividing on paper. So here we go. So we're going to start with an easy example like we have in all of the previous on paper series, if that's what you want to call it. So we're going to do 393 divided by 3. And the first thing we want to do is we want to make it look pretty. And usually we set it up like this when it's multiplication or addition or subtraction. But we're not actually going to do that with division. You're going to want to set it up like this. Okay, you're going to want to set it up like this. And the reason why is because it makes the entire process easier. So the first thing you want to ask yourself is, how many times does 3 go into 6? Okay, so this is like we're doing 6 divided by 3. And we're moving from this direction. We're not doing 3 divided by 6. We're doing 6 divided by 3. And of course, it goes in 2 times. And then what we want to do is do 9 divided by 3. Right? How many times does 3 go into 9? It goes in 3 times. And then finally, we're going to scoot that over to the very last edge case. 3 divided by 3 is going to be 1. So this is about as easy as it gets. It's very clean. 3 goes into 6, 9, and 3 cleanly. And then we can easily see that the answer is 231. Let's go ahead and look at a more complicated case. So here's a more complicated case. Again, we're going to set up 693 divided by 7, but we want to move in the direction from the 6 to the 7. We want to say 6 divided by 7, but that doesn't work because 7 does not go cleanly into 6. So instead of saying 6 divided by 7, we're going to do 69 divided by 7. How many times does 7 go cleanly into 69? We know that 9 times 7 is 63. So we're going to put a 9 right there. Okay? So again, it doesn't have to equal exactly 69. We just have to get as close as possible. And 63 is as close as possible because 9 times 7 is 63. And what we're going to do is we're going to write the 63 right below there. The next step is to subtract. So what is 69 minus 63? It's going to be 6. And again, we want to repeat this process. Can we do 6 divided by 7? Does 7 go into 6 cleanly even one time? No, it does not. So what we're going to do is we're going to drop the 3 down and we have 63. And then we do 63 divided by 7, which of course equals 9. And we find out the final answer. The final answer is 99. And you can, of course, confirm this with a calculator or on paper because we've already learned how to multiply on paper. You can do 99 times 7, and you will see indeed that it equals 693. This is a slightly harder example than the first one, but again, pretty clean, pretty nice. Can we make an even nastier one? So let's try this one here. And again, feel free to pause the video if you want to give this a shot by yourself. So the first thing we want to do is we want to say, can 7 or can 8 go into 7 cleanly even one time? No, it can't. So what we have to do is look at 70. How many times does 8 go in cleanly? It goes in 8 times because, of course, 8 times 8 is 64. We then want to subtract 70 minus 64 to get 6. Does 8 go into 6 cleanly at least one time? No, it doesn't. So we want to bring down this 6, and we have 66. And how many times does 8 go into 66? Again, it goes in 8 times, but not exactly 100% cleanly, so we have to repeat the process. So it goes in 8 times. 8 times 8, again, is going to be 64. What is 64 minus 66? Or sorry, 66 minus 64 is going to be 2. Does 8 go into 2 cleanly? No, it doesn't. So what do we do here? What do we do here? So this is where things can get a little bit more complicated. So 706, I think we can agree, is also equal to 706.0, right? Yeah, we haven't changed the number. If you're doing 706 divided by 8, that's the same thing as 706.0 divided by 8. So we're going to drop that 0 down there and we get 20. How many times does 8 go cleanly into 20? It's going to be 2. And so we're going to extend this line out. And then we're going to put the decimal there. Don't forget the decimal, because remember, the decimal matters here. And then how many times does 8 go into 20 cleanly? It goes in twice. So we, again, repeat the process. 2 times 8 is going to be 16. So let's move over to the right because we're running out of room. 2 times 8 is going to be 16. What is 20 divided by 16? It is 4. Does 8 go into 4 cleanly at least one time? No, it doesn't. So we have to bring another 0 into the mix, bring the 0 over here, and then finally the process ends. Because does 8 go into 40 cleanly? Indeed it does, 5 times. And we get 5 times 8 equals 40, which, whew, we're done. Yeah, that was a lot of work. But not too bad, right? I mean, these are getting progressively more difficult, but we're still following the same process that we were. Do we have one more example? Okay, here's another example. What do we do if we're not dividing by like 5 or 6 or 7? What if we're dividing by a 2-digit number like 31? So you want to consider 31 in its entirety. And obviously 31 does not go into 5, but does it go into 55? Indeed it does, right? It goes in one time. So 1 times 31 is 31. We subtract 55 minus 31 is going to be 24. Does 31 go into 24 cleanly at least one time? No, it doesn't. We bring the 8 down. And what do you know? Because I created the example, so I made it as clean as possible. 31 goes into 248 precisely 8 times. And of course, you can confirm that 8 times 31 does indeed equal 248, and we're left with the final answer, 18. Now, these can get pretty nasty. Like, let's try to think of an example where it's a never-ending process. Kind of an easy example where there's a never-ending decimal that we create, and we'll do this with our marker. Let's say, for example, we are doing 10. So 10, so 1, 0 divided by 3. Okay. Does 3 go into 1? No, it doesn't. But does it go into 10? Yes, it does. It goes in 3 times. So we put a 3 there. 3 times 3 is going to be 9. What is 10 minus 9? That is 1. Does 3 go into 1 cleanly? No, it doesn't. So we have to bring a 0 into the mix. Don't forget to put the decimal right there as well. So we bring the 0 down. Does 3 go into 10? Yes, it goes 3 times. So we do 3 times 3, which is 9, and we get 1. Nope, it doesn't work. So we have to bring another 0 down. And notice this pattern would just continue. Boom, boom, boom. So this is what we mean by it's still being a fraction. So 10 divided by 3 is still a fraction, right? But it's going to result in this repeating decimal. It just goes on and on and on. And this would never end. It would just be 3s after 3s after 3s after 3s. And if we were to do a more complicated example, let's say we're doing, how many times does, let's say, like 29 go into 100? Okay, so let's try this one. Again, feel free to pause the video. In fact, we should probably write it up here a little bit more just so we have more room. So how many times does 29 go into 100? Pause the video, see if you can try it yourself. All right, so here we go. Does 29 go into 1? No. Does it go into 10? No. But does it go into 100? Indeed it does. It goes in 3 times, I believe. So 3 times 29 is going to be 87. Is that right? So 87. I think that's right. And then 100 minus 87 is 13. Does 29 go into 13? No, it doesn't. So we have to bring in this decimal. So we're going to bring the 0 down. So does 29 go into 130? It does, but how many times? It looks like it's going to go in 4 times. So that's going to be 29 times 4 is 80 plus 36. If you're wondering how I'm doing that, I'm just doing 4 times 20, 4 times 9, and adding them together. So 80 plus 36 is going to be 116. And then we take the difference, which is 14. Does it go in? No, it doesn't. So we got to bring in another 0. And you can just continue this process. I think this is also going to go in 4 times. Is that right? Yep. So again, we have 116. That's going to be 24. Again, bring down the 0. And you would just eventually keep going and figure this out until it started repeating in some pattern. The reason why we know for a fact that it has to repeat in some pattern is because, again, it is a fraction. 100 divided by 29 is indeed a fraction. Do you remember when we were talking about the different types of numbers, which was one of the very first videos we talked about? If something can be written as a fraction, it is a rational number. So I'm just going to use my calculator and see what the decimal comes out to be. 100 divided by 29, and we get 3.448275862. So I don't see the pattern here, which means we probably have to take this even further. Well, I chose a good example. Let's see if I can find out. 100 divided by 29. Okay, I'm just using Wolfram Alpha. Wow, the pattern is insane. It's 28 digits long. So I obviously chose not a great example, but here, if we take a look, I'll show you what it is. So this is the result. But as you can see, it's still a repeating decimal. Obviously, this is not something we want to calculate by hand. It would be a pain in the butt. But the good news is we don't even have to take it that far. Even if we were going to calculate this by hand, you could probably stop here or here, and that would be plenty fine. We're going to talk more about the decimal system, more about rational numbers and irrational numbers later. In this video, just keep in mind how to divide on paper.